AI broke the internet again, and this week has been absolutely insane. Google releases 3 new Gemini models at once, and the headline is that Gemini 3.6 Flash is 17% more token efficient than its predecessor, while also being more capable. And the new 3.5 Flash-Lite is running at 350 tokens per second and already outperforming 3 Flash on agentic coding benchmarks. Poolside releases Laguna S2.1, a 118 billion parameter model that is the most capable agentic coding model in its weight class. Independently rediscovered an Erdos math problem that had been open for 50 years, and it ran on a single DGX Spark. Microsoft drops Mage Flow, a 4 billion parameter image generation and editing stack that generates an image in 0.59 seconds and edits 1 in 1.02 seconds while beating 20 billion parameter models on key benchmarks. Qwen Image 3.0 launches, but with a notable catch: no benchmark numbers, no model card, no open weights. Sakana AI releases Fugu Cyber, a multi-agent cybersecurity model scoring 86.9% on CyberGeom and 72.1% on TTI Realm, matching leading frontier cyber models. Alibaba releases Qwen Audio 3.0 TTS, which just topped the artificial analysis TEAS leaderboard. NVIDIA drops Audex 30B, an even larger version of their unified audio model. ByteDance launches Seed Audio 1.0, a whole new class of model that generates an entire audio scene, dialogue, music, sound effects, all from one prompt. UbTech launches the UWorld U1, claiming to be the world's first mass-produced humanoid robot, available to buy today starting at $17,000. And we have a new open-source robotics framework that takes a frozen VLA model and wraps it in a memory-guided agentic harness to get 82.4% success rate on perturbed manipulation benchmarks and a lot more. So, let's jump right in. First up, Google releases a pretty significant batch of model updates this week. It's called Gemini 3.6 Flash, and there's also a new 3.5 Flash-Lite and a specialized Gemini 3.5 Flash Cyber model. Let me break each one down. Gemini 3.6 Flash is the workhorse update here. The headline is token efficiency. According to the Artificial Analysis Index, 3.6 Flash uses 17% fewer output tokens than 3.5 Flash on the same tasks. And on some benchmarks, especially coding, the savings go even further. On Deep SWE, data curve measured up to 65% fewer tokens, so you're doing more work for less cost. Now, for the actual benchmark improvements. On Deep SWE for coding, 3.6 Flash scores 49% versus 37% for 3.5 Flash. On MLE Bench for ML research, it jumps from 49.7% to 63.9%. On OS World Verified for computer use, it goes from 78.4% to 83.0%. And on GDPVol v2 for knowledge work, it scores 1,421 versus 1,349 for the previous version. Now for pricing. 3.6 Flash is $1.50 per million input tokens and $7.50 per million output. That is actually cheaper than 3.5 Flash, while being more capable across every tested category. So you're paying less and getting more. That's a pretty unusual combination. 3.5 Flash-Lite is built for high throughput, low latency production workloads. For your reference, it runs at 350 output tokens per second as measured by artificial analysis. It's priced at 30 cents per million input and $2.50 output. And here's the actually impressive part. Despite being the cheaper and faster option, 3.5 Flash-Lite outperforms the older 3 Flash on agentic benchmarks. On SWE Bench Pro, it scores 54.2% versus 3 Flash's 49.6%. On OS World Verified, it scores 74.0% versus 65.1%. On Terminal Bench 2.1, it hits 54% compared to 31%. So faster, cheaper, and more capable than the previous generation's main model. That's pretty wild. And finally, Gemini 3.5 Flash Cyber is a specialized model for cybersecurity, available only to governments and trusted partners through their CodeMender system, not publicly. It reaches competitive performance on CyberGeom against other frontier cyber models. Given the dual-use sensitivity, Google is being intentional about who gets access and is treating this as a limited access pilot. All 3 models are live today across the Gemini API, Google AI Studio, and the Gemini app. And Google also confirmed that 3.5 Pro is actively being tested with partners, and the Gemini 4 pre-training run has already started. If you're interested in reading further, I'll link to this page in the description below. Also this week, Poolside releases a genuinely impressive new agentic coding model. It's called Laguna S2.1, and this is a 118 billion total parameter mixture of experts model with just 8 billion active parameters. Now for the benchmark numbers. On Terminal Bench 2.1, Laguna S2.1 scores 70.2% with thinking enabled, putting it 11th on the current global leaderboard behind models like Kimi K3, Fable 5, GPT 5.6 Sol, and Opus 4.8. But here's the key comparison. Every single model above it on that leaderboard has either undisclosed total parameters or is dramatically larger. High 3 at 295 billion parameters sits just above it at 71.7. DeepSeek V4 Pro Max at 1.6 trillion parameters scores 64.0, actually below it. And Inkling at 975 billion parameters scores 63.8, also below it. So a 118 billion parameter model is beating a 1.6 trillion parameter model on this benchmark. That's the story. On Deep SWE v1.1, it scores 40.4%, putting it 13th globally between GLM 5.2 at 44.0 and Gemini 3.5 Flash at 37.0. On SWE Bench Multilingual, it scores 78.5%, and on SWE Bench Pro, 59.4%. Now, Poolside also did something that I really respect here. For every benchmark they ran, they published the full trajectory of every single trial at trajectories.poolside.ai. Every step, every tool call, every output. That level of transparency is genuinely unusual for a model release and makes their numbers much harder to dismiss as marketing. They also shared 3 real case studies that are worth noting. In a 50-minute session with 181 steps and no human intervention, it built a working HTML and CSS rendering engine from a blank folder and then validated it against real Chromium output. It also optimized its own agent harness, making it 5.2% faster with 70% lower memory allocation, finding and implementing the improvements itself in an automated research loop. And in a 68-minute session, it independently rediscovered a proof to Erdo's problem number 397, a combinatorics problem that had been open for over 50 years. The previous proof was found in January 2026 by GPT 5.2 Pro. Laguna S2.1 found a structurally different construction with 8 indices instead of 6, working only with Perl since Python wasn't in its sandbox. It is worth noting that this is a rediscovery, not a first solution. But the fact that it reached a different valid proof independently is still genuinely impressive. Now, Poolside specifically notes that thinking mode is doing real work here. Thinking off scores 60.4% on Terminal Bench 2.1. Thinking on jumps it to 70.2, a 9.8 point gain. That delta is actually one of the largest thinking mode gains they've seen on any model they've trained. The awesome thing is they've released this already on Hugging Face under OpenMDW 1.1 with BF16, FP8, INT4 and NVFP4 weights, plus official ggguF and MLX builds. It's also available on OpenRouter, Basseton, and Vercel AI Gateway, and it runs on a single NVIDIA DGX Spark. If you're interested in reading further, I'll link to this page in the description below. Next up, Microsoft releases a pretty impressive new open source image model. It's called Mage Flow, and this is a 4 billion parameter image generation and editing stack from the Microsoft Mage team that generates a 1024 by 1024 image in 0.59 seconds and edits 1 in 1.02 seconds on a single A100 GPU. Now, the architecture here is actually interesting. They built 2 co-design components. The first is Mage Vey, a new lightweight latent tokenizer that uses one-step diffusion encoding and decoding, and reduces tokenization costs by 12 times on encoding and 22 times on decoding compared to standard approaches. And the second is a native resolution multimodal diffusion transformer that handles any resolution and aspect ratio from 512 to 2048 pixels without resizing or padding, with a 2.5 times improvement in training throughput. Now, for the benchmark numbers. On GenEvil for text following and compositionality, MageFlow Turbo scores 0.88. That puts it above ZImage Turbo at 0.82 with 6 billion parameters, and above Qwen Image with 20 billion parameters at 0.87. In other words, a 4 billion parameter model is beating a 20 billion parameter model on this benchmark. On CVTG2K for character level visual text, it scores 0.873. On the editing side, MageFlow Edit Turbo scores 8.271 on EditEN and 8.264 on EditCN, putting it at the top of the editing leaderboard above Joy Image Edit at 8.276 on EN and 8.125 on CN, and above Qwen Image Edit at 7.877 on EN. Now, can you run this on a consumer GPU? The peak inference memory is 18 to 20 gigabytes, so an RTX 4090 with 24 gigabytes of RAM would work. But note that the speed numbers above are from an A100. Consumer hardware will be slower. The awesome thing is they've released this already. Model weights are on Hugging Face, and the code is on GitHub under Apache 2.0. If you're interested in reading further, I'll link to this page in the description below. Also this week, Alibaba releases their third generation image model. It's called Qwen Image 3.0, and the three headline capabilities are rich content, meaning it accepts prompts up to 4,500 tokens so you can describe extremely complex layouts in detail. Authentic details, meaning it can render text as small as 10 pixels and handles photographic skin and hair texture. And deep knowledge, meaning it natively supports 12 languages and connects to real-world knowledge for generating accurate UI mockups, infographics, and multi-panel layouts. Now, here's the honest story about this launch. Qwen Image 3.0 shipped with no benchmark numbers, no parameter count, no model card, and no technical report. None. Qwen Image 1.0 launched with open weights and a technical report on the same day. Qwen Image 2.0 also came with its own technical report. This is a departure from how the previous two versions in this series were released, and it makes it genuinely difficult to evaluate the claims independently. Now that said, the gallery examples they did publish are genuinely impressive if accurate. A 9-panel infographic with physics derivations, group theory proofs, medical diagrams, and cell biology comparisons, all in a single pass with readable small text throughout, is exactly the kind of output previous image models consistently struggled with. So the target capability is real and useful. We just can't verify how well it actually works until independent evaluators get access. Qwen Image 3.0 is available right now through Qwen Chat and through their API. If you're interested in reading further, I'll link to this page in the description below. Next up, Sakana AI releases a really interesting new cybersecurity model. It's called Fugu Cyber, and this is an update to their existing Fugu multi-agent orchestration system, now purpose-built for enterprise cyber defense. For the benchmark numbers, Fugu Cyber hits 86.9% on CyberJam, which tests an agent's ability to analyze complex code bases and verify real-world vulnerabilities, and 72.1% on CTI, which tests converting raw threat intelligence reports into working detection rules. Now, those numbers are described as comparable to leading cybersecurity-focused frontier models like GPT 5.5 Cyber and Mythos Preview. And that's genuinely impressive for a multi-agent system from an independent lab rather than a major frontier model company. Now, Sakana makes an honest and important point in the release that I think is worth highlighting. They specifically say that just having access to a frontier model with cyber capabilities does not magically solve enterprise security. The reality, which they've seen firsthand working with large Japanese enterprises, is that without specialized internal talent and deep integration into proprietary source code, even a state-of-the-art cyber model will generate false positives and fail to understand production environment nuances. The model alone is not the solution. It's one component of a larger workflow. I think that's an unusually honest thing for a company to say about their own product. Now, because of the dual-use sensitivity of this technology, Fugu Cyber requires an application process before access is granted. You submit your use case and contact info, and the team manually reviews every application before approving. If you're interested in reading further, I'll link to this page in the description below. Also this week, we have 3 notable audio model releases all at once. And collectively, these tell a pretty interesting story about where AI audio is heading. First up, Alibaba releases Qwen Audio 3.0 TTS. Now, the headline for this one is simple. It just topped the artificial analysis text-to-speech leaderboard, ranking number 1 across the independent evaluation. For your reference, it also achieves state-of-the-art or near state-of-the-art results on Seed TTS Eval, CV3 Eval, instruction following, long form, and acoustic robustness evaluations. The technical contributions here are actually genuinely interesting. It uses a 12.5 Hz low frame rate speech tokenizer, which reduces autoregressive decoding costs significantly while retaining voice quality. It supports 16 languages, 20 Chinese dialect regions, up to 3 minutes of one-pass long-form synthesis, and it can synthesize from noisy, reverberant, or unclear reference speech without a separate denoising step. It also adds 86 new fine-grained inline tags for localized control at the phrase and word level, covering things like laughter, breathing, coughing, and sighing. If you're interested in reading further, I'll link to this page in the description below. Also this week, NVIDIA releases a larger version of their Audex model. It's called Audex 30B, and this is a 30 billion parameter mixture of experts model with 3 billion active parameters, built on top of their Nemotron Cascade 230B backbone. Now, if you remember, I covered Audex 2B a few weeks ago. This is a significantly more capable version of the same unified audio architecture that does speech recognition, translation, TTS, audio generation, and audio understanding all in one model. The key addition over 2B is scale. With 30 billion total parameters and a 1 million token context window, it has substantially more text reasoning capacity to bring to bear on audio tasks, while still only activating 3 billion parameters per forward pass for efficient inference. It runs in both thinking and instruct modes using VLM 0, 20.0, or Hugging Face Transformers 4, 53.0 or higher. The license remains NVIDIA's one-way non-commercial license, so this is for research use only, not commercial deployment. If you're interested in reading further, I'll link to this page in the description below. Next up, ByteDance releases a genuinely different kind of audio model. It's called Seed Audio 1.0, and this isn't a text-to-speech model. It's what ByteDance is calling a universal audio generation model. You see, the difference matters. A TTS model reads text as speech. Seed Audio 1.0 takes a scene description as input and generates every audio layer of that scene at once. Multi-character dialogue with distinct voices and different emotions per character. Background music that matches the mood. Realistic sound effects. Ambient soundscape. All generated together in one pass without any separate recording, mixing, or editing. So for example, you could describe a scene in a busy kitchen where two characters are arguing, with clattering pots in the background and a tense musical underscore, and Seed Audio 1.0 would generate the full audio, including each character's voice staying consistent throughout in a single request. It supports zero-shot voice cloning from up to 3 reference audio clips, generates up to 120 seconds per request, outputs in WAV, MP3, PCM, and OGG Opus. Now, in terms of what we don't know yet, ByteDance launched this without an archive paper, without benchmark numbers, and without a public technical report. So these are all their own capability claims. I'll flag that clearly since this is a pattern we've seen with some other seed model launches. It's available through the Volcano Engine API and through ByteDance consumer products including CapCut, Himong, and Fanky. It is a proprietary model, no open weights. If you're interested in reading further, I'll link to this page in the description below. In humanoid robot news, we have something genuinely notable this week. A Chinese company called Audex has launched what they're claiming is the world's first full-size, mass-produced humanoid robot available for consumer purchase. It's called the UWorld U1, and it comes in 3 versions. U1 Lite, which is a semi-torso unit, U1 Pro, a full-body version, and U1 Ultra, a high-dynamic full-body version. They've also released both male and female versions of the design. For your reference, the male version is 183 centimeters tall and weighs 42 kilograms. The female version is 163 centimeters and 35 kilograms. The robots have 88 servo joints, can display 300 micro-expressions, and are covered in silicone skin that reportedly feels like human skin. The key claim is companionship and emotional support. Audex has positioned this specifically for helping address loneliness. The robots can apparently recognize gaze, tone of voice, and facial expressions. Now, what was the honest reality on launch day? Speech-to-lip sync latency is claimed to be under 20 milliseconds, but the response time, meaning how long the robot takes to actually process and reply, was on the order of tens of seconds in live demonstrations. In one demo, after someone told the robot they were depressed, it silently stared for quite a long time before responding. The robot's movement also looked slow and a bit mechanical on stage, more doll-like than the video suggested. That said, Audex received over 13,000 orders on launch day, though a significant portion came from government procurement programs and demonstration halls rather than private consumers. Pricing ranges from about $17,655 for the base model up to around $145,000 for the high-end version. Battery life is 2 to 4 hours per charge. Now, I'll be honest about the framing. This is less of a genuine breakthrough and more of an interesting first consumer market milestone. The technology is clearly not at the level of the industrial robots we cover regularly on this channel, but it does represent something real. The transition of humanoid robots from exclusively industrial use to at least attempting a consumer market. Whether that market actually wants this product at this price and this capability level is a genuinely open question. If you're interested in reading further, I'll link to this page in the description below. And finally, this week, we have a pretty clever new open source framework for robotics. It's called Harness VLA, and this takes any frozen, pre-trained VLA model and wraps it in a memory-guided agentic harness to dramatically improve its performance on manipulation tasks without any fine-tuning. Now, you see, the core problem here is that most VLA models are trained for in-distribution tasks in clean, controlled environments. When you deploy them in the real world, where objects are in slightly different positions, or lighting has changed, or the task requires multiple recoverable steps, success rates fall off a cliff. So how this works is Harness VLA treats the frozen VLA as a retriable contact-rich primitive and puts an LLM-driven agentic planner on top of it. The planner has access to a small library of analytic primitives for non-contact operations like staging and free space movement. And crucially, it has 2 memory modules. Task-specific memory that stores successful parameterized action traces for future reference, and global memory that aggregates reusable heuristics and failure models across sessions. In other words, the system gets smarter the more it runs. Now, for the benchmark numbers. On Libera Pro, which is a perturbed version of the Libera tabletop manipulation benchmark that systematically adds noise and perturbations to test robustness, Harness VLA achieves 82.4% success rate. The base VLA model scores 50.0% on the same benchmark, and the strongest prior baseline, RATS, scores 43.8. So Harness VLA improves over the baseline by 38.6 percentage points. On Robocasa 365, which tests complex household kitchen manipulation with navigation, it improves over the strongest baseline by 25.4 percentage points. And on RoboTwin C2R, which is a clean-to-randomized transfer benchmark for bimanual manipulation, it reaches 58.4%. The awesome thing is they've released this already. The code is linked from the project page, and the paper is on arXiv. This came out on July 9th, 2026. If you're interested in reading further, I'll link to this page in the description below. And that sums up all the highlights in AI this week. Let me know in the comments what you think of all of this. Which piece of news was your favorite? And which tool are you most looking forward to trying out? As always, I will be on the lookout for the top AI news and tools to share with you. So, if you enjoyed this video, remember to like, share, subscribe, and stay tuned for more content. Also, there's just so much happening in the world of AI every week. I can't possibly cover everything on my YouTube channel. So, to really stay up to date with all that's going on in AI, be sure to subscribe to my free weekly newsletter. The link to that will be in the description below. Thanks for watching, and I'll see you in the next one.